to hold had, and that's 1, 2, 3, 4 bytes, an array, and we place the address of this thing in here. So far, so good? Anybody lost? Anthony, we all right? Okay. Then we do the string copy. Notice the string copy is copying from token pointer to that which is the one offset inside of temp. So we come down 0, 1, offset inside of temp, and use that address for the target. That address is this chunk of memory, so we copy it in there. And then it says delete names. Does that mean that this memory is going to go away? No, because it's still pointed at this. We're saying to delete this array. That's cool. Goes away. Gone. And then take this address and copy it in here. So names points there. And then increment names, number of names. And we start all over again. So as you can see, this array is growing. Now we're wasting some space here. Each time we go through, we're allocating a brand new pointer array, aren't we? And getting rid of the old one. But who cares, right? We get a tremendous amount of savings from this type of a data structure, because this is where the meat of the issue is. This is just an array of addresses. But it will only grow to the size which we actually need. Now, think about if we get rid of, let's say we delete Mary out of there, we want to keep had. Well, we can do exactly the reverse of this, right? Just shrink it down by 1 and have only the had. We have to identify which one. And you'll get an assignment that'll do that later. Okay, questions with this? Is it worthwhile for me to go through with breakpoints and step through all of this? Or discussion good or not?
Step through it.
Got a breakpoint set there. Let's rebuild this. See if I managed to mangle anything. We're successful. Okay. Actually, we don't even need the call stack right now, do we? And we probably don't need breakpoints. I don't need output. All we really want right now is watch. Everybody see what happened to my, oh, there it is. Okay, so we have a token pointer, and we're going to print it out. That's fine. and token pointer is Mary. And so we allocate a new array. I'm going to do that first. So notice that temp is pointing at this thing, and whatever it points at is an error, it's a problem, but it's pointing at this block, which we just allocated here. We're going to skip the for loop, and now token pointer is whatever it is plus 1. We allocate a new chunk of memory, and temp, let's see, do I have that in there? No. Temp sub num names is a bad pointer. Why? Well, we haven't actually assigned anything there yet. But as soon as we do this allocation, we have a memory location, but what's in it is unknown. Why does this display this way? Why does that stuff, all these I's and Y's and funny looking symbols, why is that showing that way?
Showing that there's in memory before.
It's always the same though.
But why that length? Why the whatever?
Isn't it showing you the allocated memory?
It's showing me the allocated memory. I only allocated, what, 4 bytes? 5 bytes. 5 bytes.
Because it doesn't run into that null until then.
What's that?
It doesn't run into that null until then.
It doesn't run into a null until then. The debugger knows that the type of temp is a pointer to a pointer character, right? So the display is going to be showing us as though it were a string. It's not a string yet because a string is characters followed by a null. We haven't put any displayable characters in there, but the debugger is doing its best to do so. The address of where we are, that chunk of memory, is 3459. Okay. Now we're going to string copy token pointer into that location, and we see that the address didn't change, did it? This address is exactly the same, but the content has now changed. So what temp sub num names is pointing at is no different than it was. It is exactly the same, except that now it contains something we can read, something useful to us. Then it says to delete num names, well, or no, delete names, and we notice that names, what does it point at? Nothing, it's null, it's been initialized previously to null, and so doing this deletion won't hurt a thing. Now if it was pointing at something else, it might cause us some problems. We might crash because we didn't allocate it, or it might get rid of something we didn't want to get rid of. But since we initialized it to null, and by the way, don't forget to do that. Don't forget to set it to null. Okay? So we're going to delete it. That's no big deal. Doesn't change anything. And now, names is still null. Temp is 34918. That's its address, and so that's the pointer to the array, the start address of that array. And now I'm going to copy the addresses, just take the address that was in here, still is there, and put it in there too. So now I have 34918 in 2 places, at temp and at names. Is that clear? Then we'll update because we just added another name in. We added a name into our array, and now we're ready to go get the next one. And we'll go back to the top, and temp or token pointer is had. It's not null. We print it out. We grab enough memory here to hold how many. Well, we have one actual name actually allocated, and then now the new one, the next one, that's the +1. And so temp now points at something different than it did before, different address, but the content of what it points at is, we don't know yet, okay, hasn't been set up. And now we're going to do a copy. Num names is 1, so we're going to do this one time. So names sub I, that'll be names sub 1. Is that right? No, names sub 0, right? Names sub 0 is this one. So we're going to copy that address into here. And we'll notice that as a result of that, temp, do I have temp sub 0 here? Yeah. Temp sub 0 is Mary, and name sub 0 is also Mary. So we now have, we've started the construction of, or propagation, initialization of this array. We've got the first one, and now we have to do the second one to put it all into place. So that's where we're going to go here. Notice we went through this for loop only one time, and then we do the string length of token pointer, which is for had, and we allocate that much memory, and we stuff it into temp sub 1. Temp sub 1 is here. We've got some memory. It's at 9E8, and now we need to string copy it. So we put had in there. Then delete names. What names was pointing at was just a single one here. So we're going to delete it. It's no longer 0. Names is pointing at 34918. We'll delete it and assign temp into names so that names will be pointing here. Increase our count by 1, and then go get the next one. That's the processing loop. Okay? Questions with that? I'm going to let this run through because I want to get back to here, which is cleaning up the mess that we've created. Get rid of this. Oops. I just wanted there. And we'll let that rip. So what we have now, names, I could do some others in here. Name sub 3. And I think that's all I typed in, is that right? Had a little, yeah, just 4. And so we have this for loop. Let's look at what that's doing. The for loop has num names as being 4. We start off with I being 0, and we're going to do I 0, 1, 2, and 3. So here's the other notation that Kenan gave us. Names sub I, and then all of that, or names plus I, all of that dereferenced. And we're going to delete that. Okay, so this first time out, we're going to be pointing to this memory. We're going to delete that chunk of memory. And you'll notice that it goes to, oops, we don't have anything. It's not what we had. Then the next time through, we're going to delete, and had goes away. The next time through, now again, why is this longer than that one?
Ran into a null.
Again, where was the first occurrence of null? Okay. So F10, again, we're looking at the A. That goes away. And we're looking at little. That's gone away. And now we're out. We still have, what we've done is we've eliminated this memory, gone. We eliminated this memory, gone. All 4 of those chunks are gone, but this array, which was, by this time, is now 4 long. It, by the way, still has these addresses in it, doesn't it? But the addresses are no longer valid, and that's shown by this. Okay? The addresses are no longer valid, but this is allocated dynamically. So we don't want to leave that hanging there. So we are going to delete names, and names is pointing to here. Right? Temp disappears after we leave the subroutine and come back into main. So now we're done, and only one last thing to do, and that's this one, which is specific to this application, where string is Mary had a little lamb. That's the original string that Token Pointer was working on. So we'll delete it, and then we're done. Questions there? You all get the picture of what's going on? It's lab 4. Okay. After you've done the static allocation of the array, where you're dynamically allocating the ragged edged, now lab 4 says do the same thing all over again, except make this one dynamic, as well as this one, these others. And also, by the way, put a search in there to look for duplicates. Keep a count. Okay? You should be well underway with Lab 3. If you wait until next week at this time to start Lab 4, you're not going to get done. Okay? Just a heads up. We have a long weekend ahead. Monday we don't have class. It's a holiday. So we will meet again on Wednesday.